Hi, this is Xiaocun Xu. Uh, I'll be talking about project number 3. So firstly, I will give a quick introduction about this project. Then I will show how I selected the candidate variable for my linear model, and how I try to came up with my nonlinear model. Uh, this project's all about figure out a model to see if the long life of dolphins is related to factors such as a social integration score, close relationship index, and intelligence quotients. The ideal model should help marine biologists to identify unhealthy dolphins. Uh, in the process of eliminating variables, it could help scientists to save experiment costs. So as you can see from this table, um, all the variables are quantitative because it represent the quantity of measurements instead of representing things like colors or simple choice of yes or no. For the linear model, I want to focus on variable selection because uh, it contradicts to my first impression about how to select variable. When I was doing homework, I just plug all the variable into an equation and just to check if the p-value fits the uh, criteria to drop the variable. So I was wondering if I should put variables in different models to see the p-value changes. So I just want to give one example to show what happened. For social integration variable, uh, firstly, I put it in a model just by itself. It shows insignificant p-value, which means we should drop the hypothesis that the coefficient is 0. So, which means we should keep this variable. Um, so next up, I put in social integration with close relationship. As you can see, the p-value has increased a little bit. Uh, it shouldn't be dropped when the confidence level is 95%. However, when we choose 99% confidence level, this term can be dropped. And so when I put social integration with other two variables together, it also increased the p-value. So it's only the matter of choosing different confidence level. The social integration could be dropped. I think this raises certain suspicions about how I should choose a variable. For nonlinear model, I made a quick conjecture by using this tool. Basically, I plug the linear model, quadratic model, and the cubic model into this tool, and it gave me the r squared value right away. I just want to see if r squared value has increased as I increase the degree of polynomials. The evidence seems to be true, and this is a polynomial with only one variable. So next, I want to test if it is true when I put more variable into polynomial of different degrees. So in SAS, my first attempt was to use this linear regression, because when I try to edit this model, I found out I can add all these different terms. But I had a suspicion, because since this tool is all about linear regression, and as you can see, the results p-value are all very large. All the terms should be dropped, so it doesn't have a promising result. So next, I try to use a scatter plot. Scatter plot can be easily used by tweaking all these code around here. Basically, you can just copy first line, change the degree into 2. However, this is only a polynomial with one variable. It seems doesn't allow you to add any model into this area. You can just take a look at the graph made by this code. It seems to me it shows the distance between the model and all these points. It seems to be closer by using quadratic model, but this is not a reliable guess. I think more reliable measurements should be based on R-squared value. And next up, I try to use this GLM procedure. This procedure allows me to edit the model. So as you can see, I only included one variable in the model. It's a cubic model. It's what I wanted, because my first conjecture about increasing R-squared value by increasing degree of polynomials. And but when I try to add social integration into the equation, it didn't give me the desired graph. The graph was not easy to interpret, and it fails to show me the R-squared value, like the video I searched. I was using so my conclusion about the model selection is all about, I think the process of selecting variable is very important. Although it doesn't make much of a change when I was figuring out which variable should I choose, it probably shows some significant change in p-value if the model has multiple variables. That's just my guess. And also, when I was figuring out the nonlinear model, and I found out the problem about overfitting. Although increased R-squared value shows promising evidence that it fits the data better, but it only fits the data. It only fits the sample data we currently have. We should test other random sample from the same population to ensure the validity of the model. I think these 2 points bring out the ethical concerns, and we should choose our variable into our model very carefully by testing it with different random data from same population. That's all I have. Thank you.